All right, this is Cisco Networking, NET-213. This is Friday. We worked on the transport layer, but we actually spent quite a bit of time prepping for a lab we're going to do on Wednesday, and we did the IP addressing for that. The students took the pre-assessment for the transport layer, and we spent a fair amount of time, again, going through the OSI model. So we reviewed the application layer and how that links into apps. And we talked about some different apps, especially some of the new apps now, how they're so network ready in terms of on devices like phones and tablets and so forth. So the application is the hook in, the presentation layer, we reviewed that, presents the data, if we need to encrypt it, or how it's going to be presented in ASCII code or whatever. Then we talked about setting up the session between where you're at and wherever you're going. Okay? And that session layer can't end until the transport layer gives it all the information it needs. So transport layer, if you're running TCP, then that's going to keep requesting segments until it gets everything and keeps track of different conversations with the port numbers. So it segments the data, splits it into segments, appropriate size, and puts port numbers on it. Network layer, IP addressing, we looked at that again in Wireshark. And then today we looked at the data link layer, the framing, the information that's put on to actually create the link between two locations. Create the link between two locations based on some protocol. And then we reviewed the physical layer. How is it actually going to represent all those ones and zeros on the media? How are they going to represent it if it's wire? In wire we use electricity, so it's going to have to represent it using electricity, maybe voltage. If it's media, might be wireless. The media might be wireless. How is it going to put it in those radio waves? Or we have a wide range of different types of waves in terms of wireless. And then fiber optics, all those frequencies of light, how are we going to make use of that to represent the ones and zeros using light going through that medium? Okay, OSI model. Then we created a networking example. So we talked about the protocol then that allows us to send information from the PC to a router or other PCs on that same network. Ethernet. And you can see the example here of our addressing for that. Then we talked a little bit, even though this scenario isn't exactly right how I have it drawn up here, you probably would have that connected to the switch rather than the router. But we can have the communications to this device, an access point. So we're talking about that wavy line there connecting a laptop to the access point. And that's using some protocol, for example, that would be using 802.11 if it's Wi-Fi. And then we have those four categories. A, B, G, or N. N being the most current and the fastest out of that group. We talked about, A is 54 million bits per second, B is 11 million bits per second, G was 54 million bits per second, and N has capabilities from 54 up to a theoretical, it's like 600 million bits per second. So we talked about the data link layer prepares the data to move through the link, and the physical layer actually moves the data. Okay? Moves the data. Whether it's Ethernet, wireless, or we did the example here also of a WAN connection, HDLC, some WAN connection between two devices. Okay? All right, then we took this address, 192.168.124, and we decided how we're going to subnet that address, to work in our network. So the only ones we're worried about today was this Ethernet connection here, this LAN connection, 10 hosts. That includes the networking device, so that includes that port up there where the .78 is, and the host on that LAN. Then our example over here, 30 hosts, and that also includes that connection up there, the .30. So we could actually put 29 other devices on that network for the 30 hosts and how we divided it up. So we started. The lines represent the bits for the part of the address we cannot change. We cannot change the 192.168.100 because we were given a /24. So we have that network to start with, so we can work with this octet, the 0 octet, however way we want. So I drew those 8 bits. Then the students calculated where to make the cutoff. So I drew a red line, everything to the left are networks, everything to the right are hosts. And that will allow us, it's exactly a 30 host, which will accommodate this right here. And so then we wrote down a few of the networks, not all of them. There would be, since we have 3 bits there on the left, we would have the possibility of 8 networks. And each of those networks, 30 hosts. So we drew out the first 4, just for practice, and then /27, right? So we have 8, 8, 8, so we have 24, and the 3 bits right there, 25, 26, 27. And if those were all ones, we end up with this mask right here for that first network, 224. Okay, so we wrote out those 4 networks. Then we took this one, the first one here, and we applied it here. Okay, and we put the last address as the default gateway on the router, and we got the mask. Then we took the second one and we decided to use that to represent our WAN. And we only need 2 addresses for the WAN. So we took that one, and so this part of the address cannot change. 192.168.132, where that 1 is there. So now we have those bits we can work with, those 5. We drew the line there because we only need 2 addresses. Those 2 bits on the right now are the host, and everything to the left of the green is going to be the network. We drew out the first one, so those all have to be the same. And so now we have these combinations. So we have actually 8, everything to the left of the green. We have 8 of those can be the network. We drew out one of them, come up with this address, and then I had the wrong addresses actually written up here, but they're corrected now. And so then we assign that one up here, and we have the 33 and 34 on that network. And then you'd have to calculate the mask. 252, I didn't write it up here, but that's what it'd be. Then we took, and I won't go through the whole thing here, but we took this third one, drew the line there. This part can't change. That'll give us 2 networks, and these 4 bits will give us 14 addresses. So we took this one, which we got from here. We wrote the 2 down, but we took that first one and we assigned it here to represent this network here. And so I'll get just an overview of the board. We got this part, and we got this part, and then we have our network for this class, and that's it.